is figure out back, front, right, left. If you get that wrong, then everything else is going to be wrong. Okay? What you're going to look for, you see this diagonal line right here? Don't look at this one, that's just where they cut the heart. Right here. That's the sulcus, that's on the front of the heart, and that's where all the coronary vessels are, in that little groove, and then covered with fat to protect them. Okay, so all the vessels that actually feed the heart muscle lie in this groove right here. You don't see that on the back. Okay, so that's the front. The apex of the heart, the point, is the bottom of the left ventricle. So everything below that line, that's left ventricle. Everything above that line is right ventricle. Okay? So front, back, left, right. Okay? Then they're telling you to look for some vessels, which you can see on the outside. The one that's most ventral, the one that's most in the front, this one right here, and it actually kind of is supposed to be lying down like this. Anyway, the one that's most in the front right here, that is the pulmonary artery. The pulmonary artery, we know arteries carry blood away, right? So the pulmonary artery is carrying blood to the lungs. So that's oxygen-poor blood coming from the right side of the heart out to the lungs. Okay? The biggest artery is the one that's right here. See this great big opening right there? Straight up and down? That's the aorta. So that's the biggest artery in the body. Okay? And then we see this little branch right here off the aorta. That one right there. That's the brachiocephalic artery. That's going to branch off for your upper chest and up your head. Okay? So we have pulmonary artery in the front, aorta straight up and down, great big one, little branch here, brachiocephalic. Okay? Then we have veins that bring blood to the heart. And the largest veins in your body, oh cripes, I can't see them on this art. The largest veins in the body are it's been cut. The superior and inferior vena cava, which actually should be it's all cut up there. It should be like so. They've cut it. The superior and inferior, if this were hooked like that. On the back of the heart, oops, I'm sorry. That's okay. The back of the heart, like this. Okay? Just pretend that wasn't cut apart there. Okay? So you have the inferior vena cava, big vein is going to bring blood back up from the trunk, and the superior vena cava is draining the upper body and the head. Okay? So all that oxygen-poor blood comes in through those two big veins, and it's dumped right into the heck is the aorta? I mean, where's the, right here. And it's dumped right into what's left of the right atrium. Okay, the right atrium is the right upper chamber. Okay, it's right here. This is the left atrium or left auricle over here. They're just like ear flaps on the top of the heart. Okay, so that's superior and inferior vena cava dump that oxygen-poor blood in the right atrium. That right atrium then contracts and sends it to the right ventricle. The right ventricle contracts, sends it out through the pulmonary artery, out to pick up some oxygen. Okay? Once the blood is oxygenated, we got to get it back to the heart so we can pump it around the body. So it comes back through 4 major pulmonary veins, 2 from each lung, that bring that oxygen-rich blood back to the left side of the heart. And they come in this big hole in the back here. The hearts have been cut so close that you can't actually see the 4 individual openings. Okay? This is where the pulmonary veins are bringing blood back, and they're bringing it right back to this left atrium. Okay? Then that left atrium is going to contract, send it to the left ventricle. Left ventricle contracts, sends it out through the aorta. Okay? Mm-hmm. Good? Okay. So then we can open it up and look at some internal anatomy. So here is the point, right, the apex. So this is the left side, which is huge, and this is the right side, which is much smaller. Okay? The left side has all of this myocardium, and in your lab it tells you to look for the different layers of cardiac muscle. You can't differentiate in these hearts. Okay? So if they put a pin here anywhere in any of this stuff, just say myocardium, because that's what most of it is anyway. Okay? But there's much more of that muscle on the left side than on the right, which makes sense if you think about what the heart is doing. The right side only has to contract with enough force to go to the lungs, right behind the heart. Whereas the left side has to contract with enough force to create enough pressure to pump blood out that aorta and around the body. So you need a lot more muscle on the left. Okay? All right. If we look at the insides, so this is the right side, the small side, okay? And this is what's left of the right atrium up here. And if we look inside there, you see all those little bumps and grooves and stuff on this? That's pectinate muscle, okay? Because the small upper chambers have to contract too to send blood down, okay? So that's pectinate muscle in the right atrium, okay? So when that contracts, it's going to send blood down into this right ventricle. To get there, it has to go through a valve. There are valves that regulate flow between the upper chambers and the lower chambers, and those are cuspid valves. A cusp is a flap of tissue, okay? So on the right side, it's a tricuspid valve, meaning there are 3 flaps of tissue, okay? So if we look, we pull this open a little bit, we look in here, here are the cusps, or what's left of the cusps. Okay, right here, see these flaps of tissue right here? You see that? That flaps of tissue? That's a cusp, okay, just that little flap of tissue, okay? And you'll notice that that cusp is attached to all these little strings on it. See them? See the little strings on them? Those are the chordae tendineae right there, tiny tendons, and those in turn are anchored to the ventricle wall by these little bumps here. Those are actually called papillary muscles. Okay, so we have the chordae tendineae anchored to the papillary muscle. And what happens is when the heart contracts, it puts tension on those tendons, and that pulls the valve closed. And when the heart relaxes, tension is released and the valve opens. Okay. Also in the right ventricle, and we don't have one of these, but sheep and cows do, and they always love to ask you about this. In the right ventricle, you see this thing here that looks like a rubber band? Yep. That's called the moderator band. And that's supposed to moderate how much the heart expands and contracts. That's what I was told. Anyway, we don't have one, but they have one, and they like to clip it and ask you what it is. All right, so that's the moderator band in the right ventricle. Okay? All right. So then if we look at the left side, let's do this one. Okay, left side. Again, you have this left atrium up here, right there. It's going to contract, and it's going to pump blood down into this left ventricle. To get there, it has to go through a valve. It's a bicuspid valve. And here's one of the flaps. Right, bi means 2. There's one of the flaps here. And I have no idea whether this is part of the other one over here. Okay? So those are the cusps. Again, here the chordae tendineae, the tiny tendons, anchored to the bumpy papillary muscle. Okay? In addition, in the bottom of the left ventricle, if we pull this open, you can see all these ridges in here. See the ridges in the bottom here? Down in here? Yep. That's another set of muscles called the trabeculae carnae muscle, and that gives the left ventricle enough force to contract hard enough to send that blood out. Okay, so we need extra muscle in the left side to do that. We don't have that on the right side. Okay? All right. Now there are also valves that regulate flow between the ventricles and the vessels leading out of the heart. So there is a valve when this right ventricle contracts, full of oxygen poor blood. It's going to contract and send it through the pulmonary artery out to the lungs. It has to go through a valve. And if we look here in this view, actually it's a really good view of the valve. Okay, so this again is our pulmonary artery coming out here on the front of the heart. We've cut the front of the heart so we can see. Right here where the pulmonary artery begins is this little flap of tissue in here. There's one on each side. That's called the pulmonary semilunar valve. The semilunar valves are literally just little flaps of tissue that kind of go like this, open and close. Okay? And since this one is right at the beginning, it's ripped on this side. Okay, but here's part of it that's still attached on that side. Okay? That's called the pulmonary semilunar valve because it's at the opening of the pulmonary artery. Okay? Likewise, if we flip this baby open, when this left ventricle contracts, it's going to send blood out through the aorta, which is this big opening here. Okay? To get there, it also has to go past a semilunar valve. And it is gone in this heart. Well, here's what's left of the pulmonary semilunar valve, right here and right here. Okay, again, it's right at the opening of the aorta. And it's just little flaps of tissue. I'll bring around another heart that has a better one. Yeah, Can't even see it on that side. Okay? But it's the same deal. It's just two little flaps of tissue right at the opening to the aorta. And that's the aortic semilunar valve. Okay? What else? Oh, they tell you to look for different layers of muscle around the aorta, and clearly that's not going to happen. So don't worry about that. They also tell you to look for membranes. There are no membranes on these hearts. Okay? You might see the pericardium or the sac around the heart on the cat, because I don't think they've cut the hearts out yet. So they might ask you what that is, but there are no membranes left on these hearts. Okay? Good?
Okay.
All right, so now just go through your lab book. Try to identify the structures.